Hello dear, welcome back, and you have started watching videos on subcomputing. So you see, we have a good news. Today is 8th May and cases are coming down, at least in Allahabad. So continue to wear mask wherever you go. Coming back to our discussion, today we are going to discuss a very important topic, defuzzification, one of the easiest topic. So why it is needed? Recapitulation. We are trying, in my earlier video, we discussed that how we can create a fuzzy inference system using fuzzy logic and their fuzzy set and all kind of operators. They are very useful. And step by step, we are discussing how to develop a fuzzy inference system. So the basic steps are, you will have to identify inputs, and once you have identified inputs, then you will have to enter in the fuzzified zone by fuzzification, right? How do you fuzzify? By designing some membership function, okay? And the inputs have a membership function. Now they are fuzzified inputs. And then what you do, you just capture human knowledge in the form of if-then rules, okay? And then allow those rules to be executed or fired, okay, in output. So in output also, you define output, and then a membership function you also define in output, right? And once the rules are fired, you are getting output in the form of in the form of fuzzification, right? So unless I defuzzify, I cannot use actually my inference system, because I will not be able to understand what is going on. So today's lecture, we are trying to understand what are the defuzzification techniques. There are many actually defuzzification techniques, but the mostly useful one we are going to discuss. The first one is maximum membership technique. Okay, say I have a membership function, continuous membership function like this. Okay, it's a combination of triangular membership function and say this kind of rectangular membership function it might be. And this maximum membership technique tells you that to get a defuzzification value, you just take the maximum, you take the elements in the universal discourse which corresponds to maximum membership value. Here X star, this has maximum membership value, which is incidentally 1. So this is your defuzzified output. So this will be your answer, okay? So it's very simple, that you calculate all the elements membership value, okay, and then it has to be maximum for all other. For example, it will be identified only here. For all other x's, it is minimum. Yeah, for all other x, x belongs to x, it has to be greater than, equal to, right, maximum. Okay, so this is my defuzzified output. You understand? Very simple, right? Now, what will happen if we have more than one such maximum membership value related inputs in the universe of discourse, or elements in the universe of discourse, just like here, say. So this is my membership function, trapezoidal, right? And it has 2 points which has maximum membership value. So what you will do, say this is my A, this is B, and this is C. So in that case, where you have a number of points, okay, a number of elements in the universe of discourse which corresponds to same maximum membership value, then you get a point which is A plus B by 2, as I have shown here. So this will be your defuzzified um, element. Okay, right? So this is extremely simple. Also, I have talked, right, that we use alpha cut to get a crisp set out of fuzzy set. Okay. Another technique we are going to, so this is also incidentally known as mean max membership technique. The technique which I told, which is very simple, right? So you have just, you will have to take the mean, okay? And then that will be your x, so this is your x optimum. Clear? Then another very popular method is weighted average technique. So suppose I have fuzzy membership function, one, two trapezoidal, one triangular. Okay, then you can calculate the defuzzified value of x equals to, by calculating um, membership value times x bar divided by the summation of all the membership value corresponding to x bar. Okay, so summation of mu a x bar times x bar divided by summation of mu a x bar, where x bar is the centroid of each of the symmetric membership function. Now look here. Okay, what does it mean? Very simple. Say I have one membership, trapezoidal membership function. It is symmetrical. It has to be symmetrical to apply this formula. Symmetrical means it has an axis of symmetry around which, if you fold, they will completely overlap. Okay, and so this is the axis, and this is the centroid of membership number 1, fuzzy membership function 1. Okay, so then same thing. Okay, this is for membership function 2, this is for membership function 3, and then x1 bar, x2 bar, x3 bar. So x2 bar is the actually centroid of fuzzy membership function 2, and x3 is for fuzzy membership function, the area covered by the fuzzy membership function 3. This is a centroid. Okay, so as for this formula, this is weighted average. Okay, weighted average formula means whoever is occupying whatever area, you are actually giving importance to it and trying to figure out the resultant value, and which will be your x star value. Okay, so here you see this membership function. What is the maximum membership value? 0.5. Maximum membership value 0.5 into resultant of this, right, x1 bar, plus what is the maximum membership value of this membership function 2 covered by the area, right? It is 1. So 1 times the centroid, okay, of this area, right? And similarly, maximum membership value 0.6 times x3 bar divided by all the membership values. So 0.5 plus 0.6 plus 1. So incidentally, x1 bar will be known, x2 bar will be known, x3 bar will be known, and all these values will be known, and you can easily calculate x, defuzzified x. Is it clear? Very simple. This is called weighted average technique. Another widely used technique is called centroid technique. It has also name as a center of mass technique, center of area technique, and center of gravity technique. Okay, so let us discuss little detail about this centroid technique. Right here, let me. So this is your mu a x, and this is my x. Okay. Sure. Y equals to this. Say. So you say, let us assume that we have 1, 2, 3 trapezoidal fuzzy membership function, and the area under those functions are like this, and then you need to calculate. So this is my output, say. This is my output, fuzzified output I have got. So I need to calculate a crisp value which will defuzzify this entire area. Okay. The formula for this is actually, the formula is very intuitive. Center of gravity. You are thinking that, okay, these are my areas, okay, and say they have some mass, and then center of gravity means if I hang, then around about that point it will be hanged. Okay, so we are trying to figure out that point, which is very easy. You see, you are taking moment of the area mu a x times x dx, okay, within a to b range, okay, divided by the area under the curve. So this is area under the curve, okay. So this is your actually y integration y dx, okay. Y is actually mu ax. Okay. Now let us see, taking a concrete example of this fuzzified output, how to calculate the center of gravity, how to calculate x star using center of gravity method. So let us see how many, in both way you can do. Actually, you see, this is my 0. Okay. So I'll have to calculate area under this curve. So the coordinate here is 0, 0, and here what is the coordinate? It is 1, 0.3. Okay, 1, 0.3. So you can always figure out the equation of this curve. Here it is a straight line which is passing through this point, and then you can evaluate this integration, isn't it? Within a definite integral, so 0 to 1. So you will get this area. Okay. Similarly, you can figure out what is the equation of this line, and then evaluating this definite integral, you can calculate the area under this curve. This way you can do. Okay. And this is more general way, because here it is triangle and trapezoid. If it has been, say, it is a Bell-Shaped or Gauss-Shaped, then this is the process you should follow. But here another simple method you can follow is that they are regular geometric figures. This is a triangle, this is rectangle, this is another triangle, this is rectangle, like that. Okay, and let us try to calculate. So how many sub areas are there? 1, 2, 3. So let us see. So this is the area. Okay, 1, say this is 2, okay, then this is sub area 3, because we do not want repetition, right? So we'll have to be careful. 4, and then this is another triangle. So this is a rectangle. And this is, say, okay. So these are my areas which I need to calculate, okay, to get the area under this curve. Okay, so this is defuzzified output. Okay, so let us calculate that. Sub area 1, this is a triangle, so half base is 1, altitude is 0.3, so half 1 into 0.3 is coming 0.15. And what is the centroid, you see 0, 1 plus 1, 0 plus 1 plus 1 divided by 3 equals to 0.67. So this is very much, you know that, right? How to calculate centroid of a triangle, and we have calculated taking only the values of the three corner x coordinate. Okay, and then I can calculate a times x, which is this. Now sub area 2, very simple. Again, it is there is this rectangle. So what is the value rectangle area? 1, 2, 3. Okay, 3, and this is 4. So 4. This is area is actually 3 into 0.3. 3 into 0.3. Okay, is 0.9. Now while calculating x, what is that x? 2.5. Okay, 1, 2, 3. So 2 point somewhere here is the um, centroid of this area, right? So we have written 2.5, and then you can calculate this. So area 3, you see, half base into altitude. So how? So now you will have to calculate this. No, let us say this is z. Huh? So what is this? This is z. Huh? So z divided by this, which is 1, equals to, you know. So this is, you already know, A, B, C, D, E, for example. Huh? So this is a triangle A, C, E, and B, C, D. B, C, D, and A, C, E. They are similar triangle. Okay, so we can always write this. Um, this one is Z. So this divided by this equals to this divided by this. Okay, so CD divided by CE equals to 0.5 divided by sorry 0. What is CD? CD is 0.2 divided by CE 0.5. So Z is equals to 0.4, isn't it? 0.4. So this is here 0.4 times. So this is the base, and times altitude is 0.2. So you can calculate very easily this. And again, how to calculate x centroid? So you need to have this point, x coordinate of this point, x coordinate of this point, x coordinate of this point. So BDC 3.6. This is 3, and you can figure out. Okay, 3.6 plus 4. Okay, this x-axis of 4, x-axis 4. So 3.6 plus 4 plus 4 divided by 3, 3.8, and then you can calculate this. So likewise, 4, very easy, 2 into 0.1, and what is the x? X is actually 5, so it is 5. Okay, and then you can calculate this triangle again. To calculate this triangle, okay, let us A, B, C, D, E. Okay, so you have A, C, E triangle and B, C, D triangle. They are similar triangle again. So same principle. You can figure out what is Z. Okay. So this divided by this, which is 1, 5, and 6. So 1 equals to this divided by the CD divided by CE, right? CD is what? 0.5. C is equals to 1. So it's 0.5. So 0.5 times 0.5 half base into altitude equals, so this is what, and then you need to figure out x coordinate of B, D, and C, and then to calculate the centroid. So for 5.5 plus 6 plus 6 divided by 3, 5.8, and then you are getting this. Okay, and this area 1 into 1, this is, and 6.5 is the centroid. So, and then last one, this triangle, okay, half base into altitude, 1, okay, and 7 plus 8, all the x coordinates, right, of these points, this point, divided by 3, 7.3. So you have got, so you can just add them together. So summation of area is 3.7, summation of moment of the area, that is A into x, equals to 18.39, and then by center of gravity rule, you can figure out this divided by this. So you got a very crisp value, 4.95. Okay. So if there is any mistake here, you have got the logic. So please do it yourself with the pen and paper. So this is your centroid method. Now we can also calculate the defuzzification value x star using, why not, this, okay. So let us calculate using weighted average method, right? So if you remember, what was weighted average method? Divided by mu A x bar, where x bar is the centroid of each shape. Okay, you now know. So let us calculate this for this figure. Okay, this is calculation. You can see here so many calculations are required to get defuzzified output. Now let us calculate for the same figure. Okay, these values. What is mu for this area? What is mu A? Mu A is 0.3 times x bar, right? So you see the x bar will be 2.5. We have calculated it, 2.5 plus, how about sorry, yeah, this okay. Um, this will be calculated when x bar is what? When they are symmetrical. Here, fortunately, they are symmetrical. So I will not calculate this triangle, right? Straightway, uh, I will take this trapezoid, another trapezoidal membership function, another trapezoidal membership function. So all output are in trapezoidal area form. Okay, so I will calculate the weighted average method x star using the this trapezoidal areas, right? So this is trapezoid, right? So what is maximum membership value? 0.3 times, so 2.5, very good. Then this is another trapezoidal area, defuzzified area. So what is the maximum value? Mu A is 0.5 times, say 1, 2, 3, 4. So 1, 2, 3. So 1, 2, and then, so this is 5. From here, you are calculating from here, right? Everything from here. 2.5, then we are calculating, right? So it will be 5. Got it? 1, 2, 3, 4. Okay, 5. And then plus this trapezoidal area, and then this membership value is 1 times you see 6, 1, 2, 3, so 1.5, so 6, 6.5. Clear? 6.5 from here to 6.5 divided by, you see, 0.3 plus 0.5 plus 1. Okay, so if you have a calculator, everybody has nowadays, so mobile phone. Okay, simple calculation. Let us calculate 3 multiplied by 2.5 plus 2.5 plus 6.5 divided by 1.8 equals to, it should be 2.5 divided by 0.3 equals to plus 2.5 plus 6.5 divided by 1.8 equals to, so 5.41. Okay, so that's it. This is defuzzified value, and it was 4.9. So little discrepancies are there, but if you can tolerate that, okay, this is the best, because calculation is much more simple than this. Okay, so this is the way you can calculate the defuzzification, defuzzified value of the output, right? So now let us try to understand how a fuzzy inference system using single node approach works, right? Say I have, again, this is a membership function, another membership function, okay, and I am writing this rule. If X belongs to A3 with 0 membership value, or Y belongs to B1 membership, fuzzy membership function or set with a membership value 0.1, then Z is this one. So this is a rule I wrote. From where? From my experience. So this is a rule I wrote. Okay, and since OR operator is there, you see OR. So you see this OR operator is there. So here the and output in Sugeno method, I told you that output always are singleton membership function. Okay, so they are just like a spike, and in Mandani they could be anything, right? But in Sugeno they are spike or singleton membership function, always output. Okay, so output is fired, rule is fired, and you got output like this. Second, another rule is fired, and you got same thing. Now AND operator is there. Okay, so minimum of these two values, you see 0.7, 0.2, so 0.2 whatever is actually firing and giving you this much value, right? So you collect this one, you collect this one, rule 3 you write, and this is very simple rule. X, if X is in A1, then Z is this, so you got this spike. After getting this, all this rule means you can have several such rules, and each rule will give you output a spike, smaller or shorter depending on the operator of the rules. Okay, and then defuzzification value will be actually, you can consider them just like a parallel force, and you can use that the weighted average method to figure out the defuzzified value. And so this is Sugeno method, very effective method, because computations here are much less. You are not calculating the area of some safe. Okay, always it is a spike. So this is called Sugeno fuzzy inference system. Now we will make a case study using Sugeno method, and in that regard we will take a concrete example. Say nowadays everybody has fuzzy washing machine. This is a household item nowadays. Okay, so how the fuzzy is working there, and of course you need to understand there is a fuzzy chip. Okay, and we'll formulate the design, concrete design, using a MATLAB fuzzy inference systems shell, okay, expert systems shell. What is shell? You see, it is without any knowledge, without anything. This is a facility provided to you. Just like if you constructed your house without any furniture, without anything, and you can load all the furniture, all the items, whichever, all the amenities which you want to build, that will be your house. Similarly, the shell is provided to you so that many unnecessary detail you don't need to work. You can concentrate on design. What is the design? If a fuzzy expert system, build a fuzzy expert system which can optimally run your washing machine. Optimally means based on, say, I have, so this is my problem, right? I have to formulate it concretely now. I am considering, say, for example, two input, dirt and grease, that is oiliness, stickiness, okay? These are the two input. You can add more input as well, say two inputs, and then output will be washing time, okay, because that's where your energy is being consumed. If you run the motor, as you know, the beater is operated by motor. Motor is actually working with your electricity, so you consume energy more. Motor, uh, more time you run the motor. So fuzzy inference system is trying to tell me that how much time, if a dart, a particular cloth with particular dart and grease you are putting, then how much actually time it will tell, my fuzzy inference system will tell. So that is a detailed design which I will take up in my next class. It will be a very, very interesting one, because now practically we'll know how to design a fuzzy inference system. First, we will show it using Sugano approach, and in my concluding lecture, we will also take up, they are similar though, we will take up how to design a fuzzy inference system using Mamdani approach. In my next lecture, I will discuss Sugano approach for designing and fuzzy expert system for washing machine, right? So the design will be done offline. Design will be done with my available data, manual washing machine. When we ran, we collected a lot of data, and expert people will tell me how to write the rules. So everything will be in the design phase. But once the design is over, once the defuzzified value you got, so input, output are known to you, then those values in the form of a lookup table will be actually burnt in a fuzzy chip. So in the chip, nothing like design will be there, right? The result of the design will be there in the fuzzy chip, and then fuzzy chip will actually control your washing machine. I believe the case study which we are going to take up is clear now. And in the concluding lecture, in the next lecture, actually, at the end, by mistake, I told that next we are going to take Sugano approach, but please read Mandani approach instead of Sugano, because Sugano will be next lecture, and next to next concluding lecture we will take Mandani method for designing the fuzzy expert system, and that's the most important one as far as subcomputing course is concerned, because you need to know how to make a design, how to solve your own problem, right? With all this background which you have built so far, right? So stay tuned, and these are my references. Okay, so again, please take precautions to make yourself safe from dangerous coronavirus. Till then, I will see you in my next lecture, where we are going to design a fuzzy expert system, okay, using Sugano approach. Thank you. Stay safe. Have a nice day. Bye bye.